Howdy, everybody. How you doing? Hope you're doing well, whenever you are. We're here for Quest 4 of Everybody Codes 2025. Oh, I did want to, I found some cool solutions. Oops, not for 4. We haven't done 4 yet. Let's see. In here, I asked what would be a good way to do it, to do the counters. I think I asked it in the video. And this person mentioned that if you're using iter tools, you can just use counts. And that turns out to be essentially what I wanted to do. In fact, it's exactly like what I did. They just do it for you. They create their own counter. But then, let's see. A commenter in the previous video used chunk by, which I think is really cool. This right here. So you can do a chunk by with equalities, and then you map them to their lane and then their max. So I think that was really cool. That had never occurred to me. I hadn't seen chunk by before, so I'll have to I'll just have to remember that in the future. Like doing that chunk by is pretty cool. Anyway, those were I thought those were a couple cool things. I'm always trying to learn. There's so much stuff in the standard library, right? Like if you've ever used C++, for example, you'll do something and then someone will say like, oh, there's a function for that. And you know, so it just takes a lot of learning and a lot of progressing. So I've been using Rust for a few years now, and still there's new things to learn and to work with. So anyway, given that, let's get on with the day. Part 1. The heavy loads mean the wagons trundle slowly along the muddy road. You sit on one of them and take in the lovely scenery around you. The village where your story began is still visible behind you. Excuse me. The grain fields spread out in front of you, rolling like a golden sea. 3 windmills are visible in the hill above the fields. A light breeze blowing through the air, but the huge blades are absolutely still. The knight points to one of the mills and says, "That's where we stop. The garrison needs flour, and because you planned the packing of the crates so well, there's still some room left." From a distance, you see an older man with a gray beard covered in flour dust. He looks distressed. Before you had a chance to greet each other, he raised his hand in a gesture of apology, shouting, "Apologies, sir, the mill is out of order." You talk for a while to find out what happened. It turns out that the gears transmitting the wind's energy to the millstones have been replaced, but the mechanism has not yet been properly calibrated. The miller does not want to risk wasting the wheat grains and wants to first calculate everything precisely before restarting the mill. The knight looks in your direction and you exchange a knowing nod. The miller hands you a list of numbers representing the gears of the first mill. Each number corresponds to the number of teeth on the given gear. The first gear on the list is connected directly to the windmill. The last gear is responsible for driving the millstone. The gears are connected to each other on the list. So here's a sample set of gears. Looks like this in practice. Okay. Yeah, so okay. I mean, this is showing the gears how they are. To calibrate the first mill, you need to calculate the number of full turns the last gear will make if the first one makes exactly 2025 full rotations. So here's an example of a larger set. The second gear has half as many teeth as the first one. For this reason, every full turn of the first gear will cause the second one to go 2 times. The same relationship is here, so it goes 2 times 2, this one here, 2 times 2 times 2 times 2, and the same here, 2 times 2 times 2 times 2. So by multiplying 6, because you get 2 times 2 times 2 times 2. No, wait, is that right? For this reason, every full turn, yeah, this will cause it to do 2 times, the same relationship between that. So this will have to turn twice. So every time this one turns once, this one turns twice. This one has to turn 4 times. Then 8, then 16. Okay, I was right. It's 2 to the 4, which is 16. I have a cold or something, so can I blame it on that I can't understand simple math like 2 to the 4? So if you multiply 16 by 2025, that gives you this. So in this example, in the second example, the relationship between the sizes of the gear no longer fit together perfectly, but you notice a faster and equally accurate method for calculating the required value. In this example, it'll take only 15,808, or it will take 15,000. Okay, so now we're going to get a much larger set of gears for our input. It says you notice a faster and equally accurate method for calculating the required value. That's a little funny. Because I don't notice it. So we'll have to think about this for a minute. I mean, I think maybe the way to think about it is this is like the number of teeth. And so we times that by 2025. And that gives me like the total number of teeth that moved. And then this number will be, will multiply. No, we'll divide. Does it always go down? Like, I don't think it necessarily needs to go down. But like what that's saying, if I multiply this by 2025, that's how many like degrees of rotation will occur, like how many teeth will spin, how many times the teeth will move this one. So since that has 75 teeth, we multiply that number by, no. We divide by 75? I think we divide by 75, then 50, then 35, then 13. I don't think that's right, though. It might be. I'm inclined to try it right here really quick. Like if we do 128 times 2025, and then we do that number divided by 64. Yeah, see, that's already not going to work. We're already below this number. The number of full turns the last one will make. Is it a degree thing? So like 360 divided by 128. 360 divided by 24. 3. There's probably something obvious with this problem that I'm missing that's not coming to my mind. Should I go back to this thing right here? 25, 9, 200 means this 75 one is going to be spin. $4,500 times? No. Where did I get 64 here? Oh, I was doing up here. Man, I'm close. I'm probably way off, is what I'm thinking. I'm the thing that's going through my mind is like, we know this one is going to do 259,000 ticks. No, it's going to do 2,500 full turns. No, wait. We're going to do a full turn, 2025 full turns, right? So this is the number of ticks. This one's going to make that many ticks. So the question is then, given that, how many ticks does this one make? Oh, we actually know all of them are going to make that many ticks. Okay, there we go. So what is it, just to be clear? Sorry, you can see this over here, right? We just need to figure out how many ticks are going to happen on the first one. And then that's going to translate to how many ticks will happen on all of them. And so the last one will tick exactly that many times, like divided by that. So, let's do that then. Okay, wait, what were we getting? Wasn't even paying attention. A list of numbers. So we're going to do a map of L dot parse I size dot unwrap it. I will remember that. I'm not going to fall for it this time. Okay, so it's just going to be input 0 times 2025 divided by input line minus 1. Like that. We got it. Okay. What did that take? 10 or 15 minutes? It took me, well, I guess I wasn't paying too much attention. It took me somewhere on the order of 10 minutes to get there after reading the problem. But yeah, the intuition that I was missing was instead of thinking about it in full turns, I think about it in ticks. I actually got there pretty quick, but I was not translating like that many ticks up here equals that many ticks here equals that many here. It goes all the way down, right? So the ticks don't change in that respect, if that makes sense. Okay, part 2. The first mill is starting to operate and produce flour. You promptly proceed to calibrate the next mill. Your notes. Okay, do I have like just more numbers? Looks like it. The gear's operation and list format as the same as the first mill, only the method of calibrating is different. To calibrate the second mill, you need to provide the minimum number of full turns that the first gear must make so that the last gear turns at least this absurd number of times. So let's keep that in here somewhere. Is that right? 100,000 million billion 10 trillion times, just 10 trillion. Based on the following notes, for the last gear to turn at least this many times, the first gear must do it at least this many times. In the second example, it needs to do it this many full turns. What is the minimum number of full turns for the first gear, after which the last one turns at least this many times? Okay, so we should probably think about, oh, I should do this too. Think about what we were considering last time is like, I think we just go, this one's going up a little bit. Like if this is 8 times, so this one has to make, in order for this one to make a full turn, it has to be 8 times this number. So that's how many ticks this one has to make. So now the question is, how many turns does this one have to make? It's the same number of ticks. This is the same number, the same number, the same number. So we take that number and divide it by this. Can I get rid of a bunch of zeros? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 9. So we have 80,000 divided by 128. $625. There we go. So again, I think it's just a math thing. We're just thinking about it the opposite direction now. We know how we need to do, how many ticks do we need to do down here? Is this number times this number. And so the question is like, how many full turns will this need? Well, we just divide that answer, right? So should we make these U sizes so we can do much larger numbers? Oops. Oh, that's not the answer. Because when you do that, but presumably that is the right answer. Oh no. Is it overflowing? Oh, what did I do? It's probably overflowing would be my guess. I don't think it is. I mean, we can verify that. So do I need to do this? Was my last number 178? It is. So 1, 2, 3. 1, 2, 3. 1, 2, 3. You know what? Let's grab this. It doesn't feel like it's overflowing, so maybe my math is wrong. That looks right, right? So that number divided by that number. Oh. How many full turns? It's like this, that number plus 1. So this is close, but I have to do I mean, this is going to look ugly, but I think what I do is I do like plus maybe what we should do is instead do this We'll say like let the numerator equal this. Let the denominator equal input 0. And then we do n divided by d plus if n mod does not equal 0, 1 else 0. I think that's it. I think my guess is it's an off by 1 issue. We got it. Okay, let me fix some of this stuff because it still looks kind of ugly. Yeah, this is n dot 3 is multiple of. Okay, so that's what I was missing. How many full turns? Like, that's what we need to think about. I got the math right initially, but the question was, yeah, we need to calculate full turns. So there you go. I think that's it, right? So compared to part 1, we're doing the opposite, right? Instead of starting at the top and going down, we start at the bottom and then go to the top. Figure out the ticks from the bottom to the top for this many times. The only issue you run in, what I was missing was it doesn't, it may not, probably does not divide evenly, and they want to know how many full turns. So that the number I originally gave was not enough. It wouldn't turn enough to cause the whole thing to happen. So, okay. Part 3. The second mill is also starting up at full capacity. The miller is regaining his positive mood. Only a third mill remains to be calibrated. The mechanism of the last mill differs from the previous one. The list of gears provided by the miller starts and ends with single gears, just like before. However, between them are pairs of gears mounted on common shafts. Thanks to this, they always turn at the same speed, meaning that if one gear makes, for example, 10 full turns, the other will also make exactly 10 full turns. The list represents gear pairs as numbers separated by a bar, such as this, the pipe character. The number of left represents the gear connected to the previous gear on the list. The number on the right represents the gear connected to the subsequent gear on the list. Sample list. Yeah, it's gonna fail parsing. So here's a sample. Here's what it looks like. Okay, yeah, so this is like a fixed thing. So the way to think about it is this one's going to touch this one's going to do this one 7 times, which is going to cause so for every 7 ticks from this side, it translates into 14 ticks on this side. So like the multiplier here is 2. And you can kind of see this in the example. Do you see how like every other one of them is the same? It is matching. The same thing with this one. It's a little harder to see, but 8 and 16 splits evenly. Okay. To calibrate the last mill, it is necessary to calculate how many full turns the last gear makes if the first one turns exactly 100 times. So given this example, so these are both in the ratio of 1 to 2, right? The second gear turns once after the first gear turns once because they're the same side. Oh, this one is the same as well. So when this one turns once, it causes this one to turn once, which causes this one to turn once. So this will have spun 20 ticks. which means this one will have spun 4 times. So 400, yeah. Now it's not always the same. Look, this is a ratio of 3 to 1. Are they always equal ratios? 2 to 1, 1 to 1, 5 to 1, 5 to 1? Okay. Let's just look at our notes. These one, they look like they divide. Yeah. There are a lot of them. So, okay, let's parse it because this one actually is going to be different. So I think I want to do that. And then I want to say, oops. Input dot trim dot lines dot map L dot match L dot split. What is the option here if it doesn't split? Let's just do L dot contains pipe. True. We're going to return gears, no, double. I guess we got to do some work in here though. Let LR equal L dot split once on this dot map LR L dot parse usize dot unwrap R dot parse usize dot unwrap that, and then we return. Oh, we don't have this LR. False. We just return gear single L dot parse dot. I gotta do usize dot unwrap like that. Dot collect. Oh, it's because I don't ever do anything with this. Okay. Okay, so we're parsing okay now. I think the thing that we had to think about for part 3 then is what is the net effect of each of the turns. So like what we're saying is like how many full turns will the last gear make if the first one turns 100 times? So we just need to know if this one turns 1 time, how many times does this one turn? If they're equal, it's effectively a no-op. Is it always less to greater? I think it is. Yeah. So we are safe there. Less to greater means that we can do some shortcuts. I think maybe the way to think about it is you figure out what the difference is, and that's going to have a multiplying effect. So this one is essentially a no-op. From a teeth perspective is the way to think about this. We're talking about the teeth that ticks. So when this one does it 613 times, this is a no-op. It's going to do it 613 times, right? This one has an effect of doubling. Is that right? Because every time this one moves 1, it causes this one to move 2. So we take this number, double it. Take this number, double it. Some of them are triple. We need to triple it. I think that's what we're doing. We can test it with this input. Yeah, how do we do this? So we start at 500 ticks. This doubles it. 1,000. This doubles it. 2,000. Divided by 5, 400. Yeah. Okay, maybe we don't need to test it. I think that will work. So we want to start with actually they're all doubles except for the first and the last, right? Huh. Could we do a shortcut? What I was thinking was we'll have to do a match operator. We can still do it. We'll do it with the input like this. So what do we get is we'll say like let start equal input 0. Like this is why I'm inclined to not do the single double and just pull out the 2 ends because they're all doubles in between. Maybe your input is different. So we're going to times that by 100, right? Now now for each of them up to the last, Oh, I can do if let gear single v. Yeah, it still looks ugly, but that will at least make it easier. And so we do so now we'll do for okay, so if the lane is 10, I only want to take 8, but I've skipped one, so 3. So I'm going to go through each gear and return and double the start value. And then like that's how many total ticks. And so it's just going to be start divided by last when we're done here, I believe. So what we'll do, match gear. No, we'll do if let gear double LR equals gear. We'll do what's happening here. am I stuck in some kind of auto command thing? I'll have to iterate. So here we say start times equals R divided by L. No. Am I not doing that right? 500 double. 1,000, 2,000 divided by 5 is 4. Okay, let's try with a basic example then. 13. What am I missing? So we start at 500 ticks. So that's going to tick 500 times. Oh, I am doing something wrong here. It's like 500 times 7 divided by 21. No, that is what I'm doing. So the number of ticks here is going to be 500 times it by 7 divide by 21. This is the 3000. Yeah, so this one triples it. This one doubles it. No effect. Times 5. Another times 5. Am I missing one? It looks like I'm missing one. Is this -2? So we start at 500, 1500, 3000, 3000, 15,000, 75,000. It does look like it's doing it the right number of times, right? This is the first one, and then we do 1, 2, 3, 4. This is the first one. 1, 2, 3, 5. No, I lost my timer. I accidentally closed it, and that's a bugger. So how am I not getting the right answer then? I'm getting 68. Man, I copy and pasted. Heck nabbit. Okay. Good old copy and paste error. I do want to clean this up, but I think that'll give us the right answer. So, hey, we did it. Not too bad. An hour and a half. Oh, that's the global time. I lost my timers. Dang it. So I don't know exactly. I'll have to go back and add my timers in. I guess maybe this doesn't this have a local time thing? Anyway, well, let's talk about part 3 first. So what is the key intuition is like the way to think about part 3, and I had it right this first time. For everyone, this ticks like this gear ratio has a doubling effect of like the number of ticks for this one. But it's only doubling because this is 5 and this is 10. If this was 5 and this was 15, it would have a tripling effect. So you just kind of need to go through the list and say, okay, what kind of effect does each of them have? And it may not have any effect. Notably, I'm using the first and the last here, and I really don't like that. So I'm inclined to say that the solution for part 3 is like this. We'll do a U size like that. Then we don't need the gear. So we'll say let mute input equal input trim lines. And then we'll do let first equal input dot next dot unwrap dot I guess map l dot parse use size dot unwrap like that. Oh, I might just collect these. Then I don't need to have it mutable. So this is just going to be input 0. Dot parse usize dot unwrap. And then the last, it's going to be input dot len -1. And then we'll do I think we just do L split once map unwrap like that. And we do first, middle, last like that. Oh, this is U size. Okay. Now this is all going to be messed up, but we can destructure it. So we can say first, middle, last, and then we don't need these anymore. Now we can just do for gear we can do for left, right, in, middle. First, I do that. Doesn't like this. So we can fold. Middle dot fold. First. LR. Ec times R divided by L divided by last. Iter fold. What doesn't like about this? Expected U size found. How is that ever going to work? That can't be the right answer, right? It's to do that, because then it'll, yeah, it goes out. Why can't I do that? Mismatch types. Expected pointer to U size. Found U size. Is this a pointer? These are. Oh, I'm destructuring a pointer is why. Okay. Okay. Does that still give me the same answer? 94135. Oh, I need to do times 100. 4457. There we go. Okay. That one looks better. I like that better. So the idea here is, what did I change? I'm just going to collect the whole input. Because I just, what I really want is the first one and the last one. And then all the middle ones. And again, this is based on like input analysis, right? So, but all the middle ones are just going to be like their pairs. So if I have their pairs, now I can, in part 3, I can get the first, middle, last, and I can just go through them and do a fold where I start with first times 100, and then I do the math and divide it by the last. Because this is, can I do this? Move occurs because vec U size, which is not my copy. Okay, I had to do some magic, but then now it's like actual values. Okay. Okay. I like that. So conclusion, how's part 3? It wasn't too tough. It looked, oh, I was going to look at my times. I don't think these are like exactly, well, I think they are because I do reading and stuff like that. It took me an hour in total. Is that right? Yeah, I guess I've been doing this for about an hour. No, it's not. This isn't quite right. It says it took me an hour and set. Oh, I've been going for an hour, but it takes me a few minutes to set up. So this is pretty close. It took me an hour in total. What was the thinking? It took me a little while to get to part 1. And then I had a bug in part 3. What was my bug? Oh, in my old code, I had copied and pasted how to get the first and last when I had used an enum. So that was a little annoying. Not too shabby, though. Let's see. How are people doing? Some of these people still have solved them really fast compared to me. I guess like there's something nice about the fact that like it's taking some people way longer too, so maybe it's not that bad. Oh, we want to look. Do I just have more stars around me? More stars around me. Okay, I presume eventually the stars will start to do something and cause me to turn into whatever I'm meant to be. Okay, should we go look at how other people solved it? See if I missed anything of. Correct. Div seal for part 2. That would have been useful. That was, I think that was one of the things I missed on part 2. It was an off by 1 issue. I did spend time on that too, so that's important to remember. Yep. The div seal, I guess, is helpful. First last gears. Oh, that is interesting. It, because the first 2 problems, you're only interested in the first and the last, you can actually use the same parser. So for example, we put this here and we do u size, vec u size, u size. Then we do like this. First, don't care. Last, we can do first, last. What? What is iter unsigned? I can't quite do this. Oh. Okay, let's try this. That does work for that one. So, last first. We'll do, it's this unwrap or 0, 0. So why do we do that? Like this one is like, if we don't have, we don't care. Like that's why that works. So maybe this is kind of uglier. It doesn't quite parse the same way for both the for all 3 problems. Like the reason this works, so because P1 and P2 don't care about middle. Like, that's the reason why this works. You'll have to let me know what you think, but yeah, that's an interesting way to think about it. Is like, but we can parse it this way for all three problems because we don't care about the first and the last. A to I for parsing here, just for some extra speed. Yeah, none of these took a long time. First, last, parse, solve part 2. The div seal is something. Something that I should definitely keep in mind. So the reason why this works is this parse is for part 1 and part 2, and then they do a manual parse here for part 3. Okay. You can do like SimD with some of this stuff, but the sizes are so small. It might be nice to try it once in a while. Because I didn't know whether to round up or round down. Yeah. Yeah. Oh, they used an F64 to do the math. Okay. Because if you like look at the input, it's clear that the way you're doing things are except for the last part of part 2, that actually wasn't the case, but it's clear that you're doing things in like integer type math way things, like you're doubling, tripling. The division is happening equally generally. Although again, that turns out not to be the case in part 2, so maybe you do use floats and then you don't have to worry about it. Rounding the wrong way. Yeah, I think you can do though. So if you do the double divide and do the int division, then you don't have this problem. But yeah, again, it looks like they're using floor and ceiling to get to the right things. So yeah, that's perfect. Excel. Actually cool. This one definitely works in Excel just because there's not a ton of logic. This is cool though, to be able to do something like that. You got to be an Excel nerd to do something like this, I think, and I am not. Okay. Yeah, pretty fun day. I did get caught up on a couple bugs. Slowed things down a little bit, but not too tough. So post your solution here. I'll have a link to the thing, and you can just go down here and post it, and I'd love to see it. Let me know what your username is on Reddit if it's not obvious, and then I'll go check out your solution. I think you can also like fork my gist or whatever, right? So however you want to submit it, I'd love to see how you solved it. Did you know about the div ceiling thing? That would have helped to know about that. But otherwise, it was a pretty fun day. Yeah, it took me a little while to come to the conclude. This part was really funny in part 1, but you notice a faster and equally accurate method for calculating the required value. I did not. It took me a minute. I mean, I eventually got there. The like intuition was think about each tick and how it affects. Like each tick here is one tick here, is one tick here, is one tick here. And so that allows you to do, once you understand that, part 1 and part 2 come fairly simple. My only problem with part 2 is I wasn't doing, adding the remainder if I needed to, missing div ceiling. Part 3 I had right, except for my bug, I think. So the additional thing that you have to intuit here is this has a doubling effect, and this one has a doubling effect, right? And so, more complex ones, this has a tripling effect, this has a quintupling effect. So you just have to like think about those things, and then you can get to your number. So these are big numbers. So if you were using U32s or I30, well, these might have fit in U32s, definitely not I32s, right? No, I don't think they would, because wasn't one of them, I think this number already exceeded a U32. I don't remember though. I think that's right. Anyway, pretty fun day. Share your results. I'd love to see them, and we'll talk to you next time. Bye, everybody.